Hey guys, my name is Shreyas. Welcome to Simple Chemistry. In this video, we're going to be learning a very important skill that you will need to know for chemistry, and that is dimensional analysis. This is probably the most important video in this unit, so make sure you pay attention. So we talked about the metric system. However, sometimes scientists don't want to use the typical units that they have to measure things. So for example, let's say you were talking about the weight of a tank, right? You wouldn't want to measure that with grams because it would be a huge number. So you'd use a number which is a little bigger than grams, like a unit which is a little bigger than grams. And the same thing if you wanted to measure the weight of something really small, let's say like an atom, you wouldn't want to use grams in that case instead. So instead you'd use one of a really tiny unit, okay? So that's where we see these metric conversions. And this is why the metric system is very useful, because the conversions are actually in factors of 10 in comparison to the US system, where you see things like 1 foot is equal to 12 inches, weird things like that. It's not always constant, but with the metric system it is. So let's look at it here. So here we have the basic unit, so that would be the things we talked about, the meters, grams, the liters, all the standard units that we have. You can go check that out in our metric conversion video, the metric system video. Okay, and then if you look on this side, these are bigger units, so you can have decameters, okay? And that would be, and if you look at the numbers here, this shows you how many of the unit are within this. So like for this, since it says 10 to the first, there are 10 to the first, or just essentially just 10 meters in a decameter. And then you can see hecto is 10 squared, kilo 10 cubed, then it starts to go up by factors of 3. Mega 10 to the 6th, giga 10 to the 9th, tera 10 to the 12th, peta 10 to the 15th, and exa 10 to the 18th. Okay? In terms of the abbreviations, so we know the abbreviations for meters, little m, so in order to indicate decameters, we'd say DKM, hectometers would be HM, kilometers would be KM, megameters would be capital MM, so on and so forth. Okay? Now and this would also go for grams too. You can have decagrams, you can have decaliters, same thing. Okay? And on the other side here, we have deci, 10 to the minus 1. So you can think of it two ways. You can say that 1 meter is equal to 0.1 meters is equal to 1 decimeter. Or you could think of it the other way. There are 10 decimeters in 1 meter. But this conversion factor is saying how many, what part of a meter equals this, okay? So 10 to the minus 1 meters is 1 decimeter, 10 to the minus 2 meters is 1 centimeter, 10 to the minus 3 meters is 1 millimeter, 10 to, again, then we see this jump by minus 3 now, so 10 to the minus 6 meters is 1 micrometer, 10 to the minus 9 meters is 1 nanometer, and then here we can keep going, picometer 10 to the minus 12, femto 10 to the minus 15, atto 10 to the minus 18. Okay? And then again, we also have the little abbreviations here. If you wanted to say, for example, decimeter, that would be little d, little m, centi, little c, little m, milli, little m, little m. Now, micro has a funny looking symbol over here. It might be hard to view. Let me write it out a little bigger for you. It looks like this. And so if you want to say micrograms, it would just be this and the little g like that, it's actually not it's not a letter of the alphabet, obviously. It's a different symbol, but it means micro. Nano, little n, pico, little p, femto, little f, atto, little a, and you put that in front of the abbreviation for the unit, the standard unit you're looking at, okay? So make sure you just memorize this chart over here. You can just pause it and memorize it. Alright. So now that we've got that covered, let's also, this is very important, 1 centimeter cubed is 1 milliliter. So if you have a little box and it was 1 centimeter by 1 centimeter by 1 centimeter, like a cube, and those are its dimensions, that would have a volume of 1 milliliter, and then 1 decameter, which is 10 let me see, 1 decimeter, sorry, I got that mixed up. 1 decimeter, which is 10 centimeters, or it's 1/10 of a meter. Okay, so if you have 1 decimeter by 1 decimeter by 1 decimeter, you'd get, that would be 1 liter. Okay, these are also important conversion factors to know. So make sure you memorize that. Alright, so here let's actually talk about the important thing here, the dimensional analysis rules. So dimensional analysis is a very, very unique way, very, very important skill, okay? So make sure you pay very close attention. It's how we can convert quickly between units. And in chemistry, you're going to be doing this a lot, especially in stoichiometry way later down the road. So it's important that you get good at this. So the rules is that you ask the question, what are you looking for? Then you start with what are you given, and then you start using conversion factors to get where you want. So let me give you a few practice problems, okay? So we have convert 45 million meters to gigameters. All right. So what we're going to do here is we first ask ourselves, let's look at this rule here, what are you looking for? So we're looking for gigameters, and if you look here, the abbreviation for that is capital G, little m. So to set this up, let's say, what are we looking for first rule? So that's gigameters. Second rule is what are we given? We're given 45 million meters. I'm going to just express this with scientific notation because I don't want to have to write that out. So this is 4.5 times 10 to the 1, 2, 3, 4, 5, 6, 7 meters. And then we set up this little grid like this. And then we start using conversion factors. Okay? So here our chart told us that there are 10 to the 9th meters in 1 gigameter. So that's our conversion factor. So again, there are 10 to the 9th meters in 1 gigameter. Okay? And then look, the units cancel out, meters cancels with meters, and you're left with gigameters. And then we multiply everything on the top, and we multiply everything on the bottom, and then we divide. Okay? So we multiply 4.5 times 10 to the 7th times 1 gigameter, and then we divide that by 10 to the 9th, and we would get 4.5 times 10 to the minus 2 gigameters. Alright? So this method of having this squares here, this grid-like manner here, is very important. You could have probably just done this with simple math, but I'd highly recommend you do it this way because it's important to know. And I'm going to be using this method later on in this course, so make sure you understand how to use dimensional analysis. Okay, so let's go ahead and do the second practice problem here. Oh my god, it didn't get anything. Let me erase this. Alright, so second problem here says we want to convert this crazy number petaliters to centiliters, alright? Alright, so we start with what are we looking for? So that's centiliters. If you look here, it's a little c, and then we're going to have to use capital L for liters. What are we given? We're given this very tiny number here. I'm going to use scientific notation again because I don't want to have to write all those little zeros. So it's 9.12 times 10 to the minus, and then we can start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to the minus 11 petaliters. If you look here, the peta is all the way over here, so that'll be capital P, capital L, peta liters, and then now we start using conversion factors. So what we can do here is, this chart tells us that there's 10 to the 15th liters in 1 petaliter. So we can use that as our first conversion factors. So again, 10 to the 15th sorry, 1 petaliter equals 10 to the 15th liters. Okay, the reason why I had to do that, I had to flip it, is because we want to be able to cancel out. If I put 10 to the 15th liters here, I would not be able to cancel out liters with this unit here. So you have to make sure whenever you're putting your conversion factor that the units are going to cancel out. So petaliters can cancel with petaliters. That's why I put petaliters at the bottom and liters at the top. Okay, very important to know. Okay, you can't just put the conversion factor however you want. You have to make sure the units are canceling out like this. So this conversion factor is telling us 1 petaliter equals 10 to the 15th liters. We got that from right here. Right, 10 to the 15 liters is 1 petaliter. Okay, and then now we can convert this into centiliters. So from this chart, we were given that 10 to the minus 2 liters, 10 to the minus 2 liters equals 1 centiliter. So look, you can put 10 to the minus 2 liters. Again, I'm making sure that the units are able to cancel out. I'm not going to put 10 to the minus 2 liters at the top, because then the units would not cancel out. So 10 to the minus 2 liters equals 1 centiliter. And then our units cancel out. This cancels with this cancels with this. And then we'll multiply the top, multiply the bottom, and then divide. And then when we do that, we will get 9.12 times 10 to the 6th, what am I saying here? 10 to the 6th centiliters. Alright. Now let's do our last problem here. So our question here says convert 0.072 attograms to exagrams. So again, set this up the same way. What are we looking for? We're looking for exagrams. If you go back to our chart here, exagrams, capital E, and then our little g. So looking for exagrams, and we're given 0.072 attograms. If you look at our chart here, that's going to be a little a, little g. Actually, let me also convert this to scientific notation. So it'll be 7.2 times 10 to the 2 minus 2 attograms. Okay, now we can first convert attograms to grams. Okay, so from this chart we know that there's 10 to the minus 18th grams equals 1 attogram. So 10 to the minus 18th grams equals 1 attogram. No, again, I'm putting this at the top, I'm putting this at the bottom because I want the units to cancel out. Alright? If I put 10 to the minus 18th at the bottom, it would be wrong. Alright? Make sure the units are canceling out. And then from here, we have attograms cancels with attograms, we're at the grams. We can convert from grams to exagrams. So we know from here that 10 to the 18th grams equals 1 exagram. So you can put that here. 10 to the 18th grams equals 1 exagram. Alright? And as we see here, grams cancels with grams. That's why this has to be at the bottom. Alright? And we're left with exagrams. So we'll multiply the top, multiply the bottom, and then divide. So when we do that, we will get 7.2 times 10 to the minus 20 minus 38 exagrams. Okay? It's pretty simple. Just make sure you understand the process here. You start with what you're given. You ask yourself what are you looking for. You start with what you're given. You use conversion factors. You make sure that your units are canceling out with the conversion factors until you get to the unit that you want. Alright? But it's pretty simple. Converting units using dimensional analysis is as simple as that.